Okay, so this is a number 9, number 5. So week 9, number 5. The topic is pH or pOH calculation. So pH is a measure of acidity in the water, and it originates from H plus concentration multiplied by OH minus concentration is always 10 to the minus 14. That's also known as KW, equilibrium constant in the water at room temperature. And having said that, this becomes pH, and the pOH value is plus 14, and so that's another equation that is as a result. That just happened to be the property of the water, and we just using that as an equation. So a solution of this, so that means a calcium hydroxide, which will be dissociated into calcium 2 plus aqueous with OH minus aqueous. But there are two of them for the balance, and which has a measure of pH of 11.60. So there's a pH meter, 11.60. And so this means that pOH can be calculated as a 14 minus pOH, which is 14 minus 11.60. That is a 2.40. And from here, from here, we can calculate the OH minus concentration, which is exponential to minus pOH. So, not exponential actually. It is a common log, so it's a power of a 10. So it's a 10 to the power of 2.40. That is a concentration of OH minus ions in this solution. And if you plug in this equation, and then we will get roughly 4.0, 10 to the minus 3 molar concentration. Okay, so I can see that. So what is a molar concentration of not OH minus but calcium hydroxide solution in here? So as you can see that 1 moles of calcium hydroxide will generate 2 moles of OH minus. So what they want is number 1, they are interested in CHOH2 concentration. But we do know OH minus concentration. But now you are going to use a unit conversion, which is 2 OH is 1 CaOH. I guess I need to say mole, right? So that's a molar ratio. So therefore, I am going to write 4.0, 10 to the minus 3, multiplied by 1/2, then leaves me 2. 2 times 10 to the minus 3 molar concentration, and that is a concentration of calcium hydroxide. And this one has an additional question that what is a molar concentration of another solution if the solution is diluted to the new pH that is 10.60. Okay, so what used to be 11.6 to 10.6, they are asking this to calculate this one more time. So this question is pretty much redundant. So okay, so new pH here is 10.60. pOH is 14 minus 10.60. That's 3.4. And OH minus concentration from pOH, 10 to the minus pOH. So 10 to the minus 3.4. If you plug that into your calculator, you'll get this number, which is 10 to the minus 4 molar. And then therefore the concentration of OH2 molar concentration is same as OH minus concentration, 2 moles of OH is generating 1 mole of CaOH2, so therefore 4.0 10 to the minus 4 times half, so that's a 2.0 10 to the minus 4 molar. So that's a new concentration before when you dilute it. One thing that I think that they meant to kind of tell you in here is the meaning of the log scale. If you look at this 11 versus 10, the change in this pH in the log scale, you're seeing this order of magnitude is changing this way. So that's what it was related to. Whereas the decimal part, 0.60, it used to be 0.60, that is being retained. That is actually has something to do with the number in this portion. So the number pH, for example 10.60, this is essentially order of magnitude related, and the details of this portion is related to here. Okay, thank you for your attention, and this will be the end of the week number 9's discussion problem set solution.